All right, thanks everyone for coming. So this session is the learning SQL so that you can build effectively too. Really here for this was a SQL 101 presentation we did for our chapter. And the idea there was trying to relate SQL to like Excel, things that people are used to doing. So they don't feel so daunting. It doesn't feel so daunting to get into SQL. So really trying to relate tables and queries to things you probably already do every day in your work. Things that you're comfortable doing so you might become more comfortable in querying your own data. So this was put together with the three of us up here and Paul Alvarado, who is not here right now, he's on paternity leave. There's one point here I want to make is that this presentation has been shared on the ASU Data Community channel, and it's going to continually be updated. We're adding more and more. So far we've gotten from the introduction, we started adding in joins, and if you have the link, you can continually go into that presentation and you get the new content. It'll be about once a month we'll add more content. So as you see here, we need to talk to you about SQL in general, the tool we have available, how to pull down data, and to get some basic querying and joining. So there's the three of us up here. I'm Tod Kemper. We're all in the same department, the data analysis and visualization team. And we all have very similar roles, as you can see. This is Varun Shourie and Hailey Stevens-Macfarlane.
Thanks, Todd. Okay, so first off, we'll go over a quick overview of the data landscape at ASU. This is a very partial and oversimplified version of how data flows through the different parts of our data stack. So obviously you have to get the data from somewhere, whether it's an application or tool that we have, and that data flows through an ETL process to our database, whether it's Redshift, AUDB, or our data lake. And once the data is in those data warehouses, we can use data connections from the AWS workspace to connect to that data from our various reporting tools like DBeaver, Tableau, or SharePoint. And then after we build those reports, that content is synced over to our analytics portal where all of the customers can view the information. So there's a couple different places where we can get data at ASU, and two of the big ones are our reporting data warehouse and the user databases. So the reporting data warehouse is Redshift, and that's where you'll find your enterprise level data that's curated and oops, sorry about that. That's where you'll find your curated data. In the analytics user databases, it's where you'll find data that's more like made at a department level, or you'll find some data like census information is in there as well. User databases will have information that we as developers can add to it, whereas the reporting data warehouse is more at an enterprise level. So now we'll get into SQL. So what exactly is SQL? Well, it stands for Structured Query Language, and at a high level, it gives users the ability to access or change a database. There are different types of SQL, like Redshift might have a little bit different of a syntax than what you'll see in the user databases. And an example of that is shown here on the screen. So the same type of function that you would use in one database might have a slightly different name, slightly different syntax for another. So one thing to keep in mind when you're learning SQL, learning how to do something, if you're searching for instructions on how to perform a particular task in SQL, you always want to include the type of database that you're looking for because of those differences. Next, we'll provide a quick tour of DBeaver, and DBeaver is the tool that we use on the AWS workspaces to access data. To start, the table shown here provides the information that you'll need to connect to a database within DBeaver. We aren't going to show how to set up these connections today, but we have provided links to the knowledge bases that have detailed instructions on how to do so. This screenshot shows 7 different features or sections in DBeaver that are used very frequently. We'll explain these features in the next slide. So number one is the drop-down menu that you'll use to create a new SQL query. Or if you wanted to open existing query, you could do so through that main file menu. Number two shows you which database your query is currently connected to. And number three is a list of database connections that you have access to. One really cool tip is you can expand each connection to view its schemas, tables, and even the columns. Number four displays the menu that appears if you highlight and right-click on your query. This menu is really cool. If you can use it to automatically format your SQL or do things like change your text to uppercase or lowercase, and there's a few other cool functions in that menu as well. Number five is the button that you can use to run a query, and you can also use the Control-Enter keyboard shortcut. Number six is the button that you can press to show the number of rows that your query has returned after running it. And number seven is the button that you can use to export your data to a CSV file. Most of the examples that we'll be using for the rest of this presentation use data that's stored in AUDB, and this data is just a copy of Tableau's sample superstore data. For those of you who are not familiar with it, basically it's just a database that you might see for a store like Walmart. It has information like customer ID, order ID, product information. Next up, I'll pass it over to Todd.
So that was a quick, a big dump about SQL in general, the tools we have. And now I wanted to go into showing Excel with data you're normally seeing, how some of those words and some of those terms, how they relate to things you normally do. So you saw the sample table before, and you saw that there were data in rows and there were columns. And this is to show in a spreadsheet. It's the same type of information. So you'll see the first, row number 2 has a single set of data, right? And that's going to be one record of data. It's going to be all the things that, like we talked about, shipments, orders, order IDs. And then the column is going to be a row of data. So that's a record that you could pull from. You'll even see on top, the names, the headers are the same as the table in SQL. So there's nothing really different, it's just where you're pulling the data and how you're doing it. And here's that same information within a database table or a view. See, that's still the same order ID. You got the row and all the different information, but now it's just located in a table instead of a spreadsheet. A lot more people can access it. You can do a lot more things with this. If you're familiar with pivots, if you're familiar with Power BI, Power Query, it's all very similar, but in a tool that you're normally using. And so here, again, we talk about column headers. We can, just like you can in Excel, you can rename those column headers. Like I can change it from product name to prod NM, or the other way around, whatever's easier for the end user. You can do that same thing in SQL, and we can show that here very soon. So see here the customer name. So within your SQL, you could change the code and say, call it this. I want it to be shown this way when I get results or in the coding. So it's just like the spreadsheet in SQL as opposed to Excel. And so it doesn't actually change the value in SQL. You're aliasing it. You're just calling it something else. You're not updating the actual table. And so another thing here, you're used to Excel with different tabs. You have orders, people, returns, whatever it might be. It's very similar to or even different spreadsheets. So you can have tabs in a sheet or workbook, different spreadsheets. In SQL, within a schema, there are different tables, just like different spreadsheets, different tabs. They contain different information that could be related to each other. You can think of a schema like a workbook or a folder. It's data that's related to each other, and you want to organize them that way. Back to Hailey for a foundation on. Now we've seen the tables, we've seen it in Excel. Now how do I actually use it?
So this table here shows 8 different SQL clauses, oh boy, and the order in which they must appear within a query. Right now, we're only going to focus on 4 of these. The first of which is the select clause. This is, in most cases, going to be the first one you see in a query. And this clause is where you're going to list the columns that you want your query to learn. So like select Ample ID, for example. The second clause that we want to talk about is the from clause. This is the clause where you're going to list the table that you want to pull your information from. The next clause is the where clause, and this clause is used to filter the records that you want your query to return. There's other ways you can filter, but we'll go over those later. And the final clause that we'll start out with is the order by, and this is the clause that you're going to use to sort the records that your query returns. Next, we'll go over a few basic examples of query syntax. So all of the 4 examples shown on this screen are going to return the same exact information. Each of them are pulling in 2 specific columns from one table. And they do a little bit of different things in each one. The first example on the top left is the most basic. It's just selecting the 2 columns from the table exactly how they are. The second example on the bottom left adds the schema name to the from clause. And the only thing that you need to do for that is just add a period in between the schema name and the table name. And you'll often see that in queries, especially if the same table name exists in more than one schema. You want to put the schema name in there just to prevent any confusion or any errors in your query. The example on the top right takes that table name and adds an alias to it. So in this example, the table's actual name is table name, but we are aliasing it as student data, and adding an alias can help make your query a lot clearer, especially if you have a really long query, you're returning lots of tables. It's just a way that you can help organize your query a little better. You can also add aliases to column names, and it's formatted in a similar manner. All you have to do is write as, and then what you want your new column name to be. The next syntax item that we want to introduce are comments. And there are 2 different ways that you can make a comment. One is for single line comments, and the other is for multiple line comments. For single line comments, all you have to do is add 2 dashes in front of the comment, like the example here on the left. For multiple line comments, you want to add a / and a star to both the end and the beginning of your query, like the example on the right. One really great use of comments is adding some basic information about your query, such as who wrote it, what it does, what project it was for, where you can find more information. So here's an example that uses some of what we just learned. In this example, we're again selecting 2 specific columns from one table. We're having an alias both for the column names and for the table names. And one thing that I wanted to point out is in the column names, you see that the raw data, there's a space between customer and ID. And that's not something that you'll see often because it's not really best practice. But if you do come across it, that's when you'll need to use those double quotation marks in order to pull that information. In most cases, when you see a SQL query, you're going to see the single quotes. And those typically are when you are referring to things like a string value, whereas the double quotes are most often referred to objects. So next, I'll pass it back over to Todd.
So again, keeping with this theme, so similar to in Excel, you might be used to removing duplicates or running pivot tables. So there's a lot of different ways to get a distinct value, and these are pretty common through any type of business analyst type work. So you could grab the list, remove duplicates, and now have a distinct list of values. In a pivot table, the same way, I'm putting the data in there, and I'm only getting those records just for those unique combinations. So now the same thing can be done in SQL by using the keyword distinct. So I'm doing the same thing that Hailey had shown with I'm putting distinct, so I'm only getting one value for each combination. I can also group it. So this is similar to the pivot. So I'm saying give me these, but group by these two values, similar to how a pivot table does. We're not adding any numbers at the end of the pivot, but we're still saying group on these two records. So I only get one for each combination. And the group by is really valuable, similar to a pivot. So if I'm grouping by those two, and then if I added like a numerical value or a count, it's giving me the sum of whatever, or how many of these within the combination of these two records. As far as filtering. So I'm filtering whether it's a pivot or whether it's or just a list, you can add that drop down and say, give me between these records or just these certain numbers or just this month. The same thing can be done in SQL. And that's where that where clause comes into play. So on this, we have the select statement, we have the from, and now we're adding the where. We're saying whatever that column one is greater than 999. There's a lot of other operators here and different examples of filters you could add. So we have string filters, or statements and statements, and you can even do nots. And then you see that list with the single quotes that Hailey had mentioned. And the goal here is you want to just get down to the data you're trying to work with and not the whole database or the whole table. Another example is sorting. Same menu in Excel where I want to sort it from largest to greatest or alphabetical order. And it's very simple to do in Excel, but it also is in SQL. You'll see here we have the order by statement. You pick the field, you do ascending or descending, and continuing on, you can have layered sorting. Everything in SQL has order that matters, so it goes one by one as it sorts. It's another example of, so we're ordering by the first column ascending, and then the second column descending, or inverse. So here's some examples. So the natural data order, if you do not add sorting, it's just going to give you the data as it's shown in the table. Now, if we do ascending, it's by region, you'll see it's now changed. So here I'm going to hand it off to Varun. We talked about grouping, and this is when we start getting into numerical values and start aggregating data.
Thanks, Todd. So aggregation in Excel is actually pretty similar to SQL. As you may or may not know already, depending on your familiarity with Excel, pivot tables allow you to do your necessary aggregation, and pivot tables have filters, columns, rows, and value shelves. And as a result of that, you can make pivot tables that sort of look like this on the bottom right corner of the slide, with fields on the columns and fields on the rows as well. But when you are doing aggregation in SQL, think of your aggregation as having only row shelves, value shelves, and filters. Everything is collapsed into rows and values. So here's an example of that. When you do an aggregation in SQL, everything is collapsed into rows with repeating values. And so for the years and item fields, we see that the values are repeating. And this is not user-friendly for showing this to your manager or your boss, but BI softwares like Tableau or Power BI use this to perform aggregation under the hood. So that's sort of the driving mechanism there. In terms of syntax for performing aggregation in SQL, it is very similar to what you've seen thus far. We have the select clause, the from clause, and the where clause. The select clause for picking your columns, the from for picking the table, the where for filtering your data. But the two new additions here are the group by and having clauses. The group by clause is for specifying which column you want to aggregate on specifically. And then the having clause is to filter on your measures after the aggregation is complete. So the difference between the where clause and the having clause is that the where clause is done before the aggregation. So if you want to filter on your data before the aggregation happens, then use the where clause. But if you're doing it on after the aggregation on your measure, like your sum, count, max, min, so on and so forth, then you would want to use having. To further illustrate the difference, I did the same thing in Excel, but as you can see, the where clause is equivalent to adding a field to the filter shelf in the pivot table, whereas the having clause is equivalent to doing a value filter. So both can filter down your pivot table as necessary. In the next slide, we show some basic examples of aggregations with the group by clause. These slides are posted to the ASU data community channel, so please don't worry if you cannot read the text. They're out there and ready to be viewed. But these are just some very basic examples, like aggregating total profit by a region and counting the number of orders for a specific customer. Aggregation without group by, on the other hand, is kind of funky because you're just summarizing the entire table or spreadsheet in a sense. And if you sum up a numerical value for an entire table, it might not make sense. But one of the use cases for aggregation without a group by clause in SQL is to summarize the number of rows in a table. And for that, we do select count star as basically the row count for your table. And here are a list of the aggregation functions that you can do in SQL. Many of them are very similar to Excel as is. You know, your sum, average, max, min, count. But the one thing I do want to spend some time on would be the count distinct column name. This counts the number of unique alphanumeric values for a specific column. And this is important because if you don't know what makes a row unique in a table, as in what is the grain of the table, then you're going to have to mess around with the count distinct by throwing in potential keys and IDs in there to figure out what makes a specific row unique in a table. And please note that if your table is developed correctly, count distinct star will return the same number of rows as count star. So bringing it all together thus far, here is sort of like a mini cheat sheet that you can use. We have the select clause to pull the columns, the from clause to pull the table, the where to filter your table before the aggregation, group by to perform aggregation, having to filter on your measures, your aggregated numbers after the aggregation, and order by for sorting. We haven't explicitly covered limits yet, but limit is just sort of limiting the number of rows that pop up in your query after you run it. Now we can move on to joins, and I will hand that off back to Todd.
And I want to add on that limit. What's really good for that limit is to sample your data. So you're not trying to learn your data with the entire data set. And if you want to just get 100 rows and look at it, play around with it, start to understand what you're looking for. So again, in the tradition of comparing Excel to SQL, on the joins, it's very similar to the VLOOKUP function. So we talked about how you're having two tabs or two different worksheets, and I might want to add shipment data to my orders. Or so here we have a reference table that's kind of combining the order ID and the customer ID, and it's got some order information. But I might want to bring in the product information to that order and or which customer belongs to which order and different things like that. So we would normally do a VLOOKUP and say, show me on this other sheet the order ID on the other tab and bring in other information, whatever other column. So there's that VLOOKUP now. They will combine it by the VLOOKUP of this column through the whole sheet on the other and give me the number 2 only when they're exact matches. Now, how does this tie into SQL? So again, it's what I mentioned earlier. It's returning a value when something is equal on the two different data sets with different sheets or different tabs. And then for here, we can't find the customer ID, we get that NA. So Excel doesn't like that But SQL just doesn't return anything, so there are no other routings that match. And so when we do an inner join, it only gives us records that exist in both tables. We'll get into a lot more detail in different types of joins. We're just trying to relate it back to a VLOOKUP. The left join would be, give me everything in the one table, and then just add on the new fields, and the right join is the inverse there.
So before we go into our SQL examples for joins, just wanted to let everyone know here that we've been working with the Tableau Superstore orders table thus far, but really Tableau Superstore orders table is actually a combination of 4 tables. And what we did for the joins example is we did what is called normalization on the Tableau Superstore order table. And what that does is it makes these tables much cleaner and it makes these tables much more maintainable in the long term. And that is a good thing. And it's also a very good rabbit hole for you to get into if you are interested in data architecture. So that's sort of what Josh Johnson does in the data architecture chapter. The first table that we normalized our Superstore orders table into the customers table. Customers table has information about every customer. The grade of the table is 1 row per 1 customer. So every customer is identified by a customer ID, and if there is the corresponding information for each and every customer. Same thing with products. Each row has information about 1 product. Same thing for orders. Each order ID is associated with a specific order and can be linked with a customer as well. The order details table is what you would call sort of a bridge or a crosswalk table. We call it that because it's really linking the order and products table in a way such that we can identify any transactions that are currently going on for the Tableau Superstore. And in this case, it sort of looks like a receipt, right? Like what did the customer buy in their order? And it lists out the order ID and then the product ID, how much the customer bought, what the sales was, what the discount was, what the product was. As a result of this crosswalk table, we can sort of link both tables together and get the necessary information. So now I'm going to pass it back to Hailey, who will talk about our joint examples.
Thanks, Varun. The first example that we'll go over will be an example of an inner join. So an inner join will return the rows that are present in both tables, depending on whichever fields that you use to join the two together. So in this example, we're looking at the order details table. That's our left-hand table. And the left table would just be the first one that you have listed. And our right table, the second one that's listed, will be the product table. And we're joining the two on product ID. And we're also adding a filter where product ID is equal to the ID that represents Staples in this particular example. So what we have returned here would be all of the order IDs that contained at least one purchase of Staples. The next example that we'll go through are left joins. So for left joins, what's going to happen is it's going to return all of the records from the left table and those that match in the right-hand table. So what can happen there is you'll start to see a lot of nulls, and that's okay, that's expected. The nulls are just the rows where there was not a matching record in the right-hand table. A right join is very similar. The main difference is it's looking at all of the records from that second table that you have listed instead. So in this particular example, what's happening is on the left hand, we have basically all of the orders, and on the right hand, we have just the orders from Staples. And because we're looking at, we're doing a right join, the result is only going to return the records that have the staples. So a right join isn't really very useful in this particular example. There's also a couple other joins that are less common, but still very useful. The first is a left outer join, and that's going to return all of the records that are in the left table, but it's not going to return any from the right-hand table, including those that might be present in both. The middle example is a full outer join, and that's going to return everything, regardless of if there is a match or not. And the final example is a full outer join, but with exclusions. So in that particular example, you're going to return records from the left table and the right table, but you're not going to return any records that are in both. And I'll pass it off to Todd.
Those last joins, if you're working in Alteryx, they're really helpful to understand, because that is how joins work in Alteryx, is they break them out in those 3 different ways. And you kind of have to combine them after the fact. Or they have the inner and then the left and the right. So it's good to understand how those work. Something we like to add. So anything for SQL is beyond this presentation. We have it in the channel. Please ask questions there so everyone can get the answers. There are SQL support hours held by Josh Johnson. There's a Slack channel that you can ask questions or even sign up for the support hours. And then this same 101 session, we're going to continually update, and we might even open it up to have some like regular sessions through Zoom or in person. And there are a few external resources you can learn it, the SQL Zoo, where you can practice, you can learn. Same with the W3 schools and multiple YouTube courses. And there's even, sample interview questions out there. So if you're going for a job, you can have, kind of get an idea of what they might be asking you. So there's some recap slides. It's more appendix, just to give you an idea of what's out there, just to give you you can expand on the tables, the connections, the views. This is where the data is. That concludes our presentation, but this continues on. There's a lot more in there. And if you can access it whenever you'd like, you can ask us questions, you can ask Josh questions, and then the whole community on Slack. Thank you.